it's like an odd number. That's why.
Yeah. Okay.
Weird.
Um. So, um, how do I make a pattern out of this? That's the thing I'm confused about. What do I say? The sine n pi over 2 is equal to 0 if it's even, and if it's odd, so you only want odd numbers here, right? n equals 4 is going to get you 0 again. So yeah, so you only want to have n to be an odd number. So that makes sense to say it's n is an odd number, right? So it's 2k plus 1 for some k. And then you want to just have uh, alternating. So if k equals 0, then you want to have a positive 1. And then if k equals 1, then you're going to have n equals 3, which would be negative. So yeah, so that's negative 1 to the, well, not to the k, because again, if k is 1, k is 1. No, shouldn't that be to the k? Yeah, that should be to the k. Why to k plus 1? If k, so I'm going to say if k equals 1, then this is negative 1. And if k equals 1, then n is equal to 3, which is negative 1. So that matches up.
By the way, k starts at 0, right?
K starts at 0, yeah.
Okay.
So if k was 0, then this would be positive 1, and n would be 1, and so we get positive 1. So it looks like it really should just be negative 1 to the k. I don't know why it's negative 1 to the k plus 1. Honestly, let me look at what Andy did. He posted his full, he posted the full, like, his solution to the question.
Yeah, by the way, are you recording?
Yeah, I actually pretty much just started about 3 minutes ago, so sorry to
Okay.
anybody watching. I forgot to click record for the first beginning. Thank you for checking. I really need that for some reason. I really can't remember to do that. Let me look at lecture notes there. Final exam review. Okay, so period is 4 second, DC value, that's fine. So yeah, he goes right for, oh, he doesn't do this. He leaves it like that. And then he draws this table, but then he does nothing with it, which is weird. But I don't know. What. There's nothing to even say, really. That's just how it is. And yeah, they do Fourier series. He's doing Fourier series weird. I have no idea how he's doing the Fourier series. I don't know why his bounds are 0 to pi over 2. I have no idea what that means. Any of that. My Fourier series, just doing it the math way, got us the same answer, right? Which makes sense. There's only one Fourier series of a function. But yeah, I don't know why it's like that. We should probably figure that out. But
By the way, I have a question.
yeah.
So, what we have here is -1 to the k. So that means that when k is equal to 0, n is equal to 1, and that means the answer is a positive 1.
Yeah.
So, isn't it like why does he have -1 to the k plus 1?
Yeah, I have no idea. It really seems like it's not k plus 1. That's not what this is equal to.
Yeah, because if it's 0, then it's just a positive number. Also, just one more thing. Andy does it in a weird way because he uses something called psi or something, and
Uh-huh.
he said that like how we do it is how he does it is completely different from, or actually not completely different. It's just like he makes the n pi t into just like I don't know, like he converts that into like one variable, and then he does it in a weird way. But he said that if we do it this way, that's fine too.
If we do it like the math
Like
way,
the normal way, yeah.
the normal way of doing it, yeah. Because I have really no idea what he's doing there. I mean, I probably could figure it out, but at the moment,
Yeah, we just don't have enough
we
time.
don't have enough time to figure that out this second. Okay, well, anyways, we got the right answer. Like, the answer is not wrong. It's just doing a Fourier series. But, it'd be just nice if we could get it in a way that, matches the solution. But it's okay. Find the coefficient for the sine component. So again, it's going to be the same thing. It's going to be Bn is going to be 1 over 2 integral from -2 to 2 of the function f of x sine n pi over 2x dx. And I'm going to break this up, right, into, 1/2. So the only time the actual pulse is there is from 0 to 1, I think. 0 to 1. So this is just the integral from 0 to 1 of f of x, and it's 6, right? F of x is 6 there. Sine n pi over 2x dx. So this is 3 times 2 over n pi, negative 2 over n pi, cos n pi over 2x, evaluated from 0 to 1. Yep, that looks right to me. And then, so cosine of 0 is 1, so we do have to account for that. And then, and we just put 1 here. So it's going to be 3, and then negative 2 over n pi cosine of n pi over 2, okay, plus 2 over n pi. Yeah. And so I get, 6 over n pi minus 6 over n pi cosine n pi over 2. And cosine n pi over 2, I don't know if that is anything interesting. Apparently,
Just 0.
0? Let me see.
Yeah, because cos of pi over 2 would be 0, cos of 3 pi over 2 would be 0.
Yeah, that does make sense to me.
Actually, wait, never mind. If n is an odd number, then it would be 0, no?
If n is an odd number, but if it's an even number, yeah, then it would
Yeah.
just be pi, right? Yeah, we're skipping one in there. Yeah. So if it's a even number, it alternates between -1 and 1. Anyways, they don't. I think in Andy's solution, he doesn't do that again. Let me just check that quickly. I don't think it's necessary. Well, it's definitely not necessary, but I don't think it's even expected of us. Yeah, it's okay. So I could just write here, I'm going to factor out he factors out a -6 over n pi. So it's going to be cosine n pi over 2 minus 1. Oops, minus 1 like that. But it's the same thing. Yeah, we got the same thing. So, okay, as long as the regular Fourier series works, then we can figure it out. Let's try 15. Oh, I lost the page. Okay, so the next part is the actual circuit application. So approximate Vs by its DC component, the first sine term, and the first cosine term. Calculate the response VO of t for the following circuit. Okay, no problem here. So the DC component. Okay, so hold on. Let's look at our function first of all. F of t, or Vs of t, is equal to, so it was a 6 over 4, I think, was the DC component. 6 over 4, which I'll just write as 3 over, well, I write as 6 over 4 because it doesn't matter, whatever. Plus, and then the first sine component, so there's our an, so I'm going to set n equal to 1, so it's going to be 6 over pi sine pi over 2, right? 6 over pi sine pi over 2 cosine of cosine of pi what? Wow, there's a typo in my math notes. Ah, how did I notice that? Okay, pi over 2x. Yeah, okay. Plus, and then I want to bn, but n is equal to 1, so it's -6 over pi and then cosine pi over 2, so plus, not times, cosine pi over 2 minus 1 sine pi over 2x. Yeah, there's a typo in my mouth as well. Okay. Anyways, that is the function here. So sine of pi over 2 is I have to remember 1. So this is just 6 over 4 plus 6 over pi cosine pi over 2x. Cosine of pi over 2 is 0. Yeah. So it's just 6 over pi sine of pi over 2x. Okay. That's fine with me. I think that worked. Yeah, good. Yep, this is correct. What I did right here. Any confusion about what I did here to get this? Okay, let me know. I'm happy to explain. Okay, so there's my source. So I know, I can say VO is equal to VO prime plus VO double prime plus VO triple prime, right? One for each. It's it's a linear system, so it's a one for each of these. So to calculate VO prime, we say that the source is a 3 over 2. Well, I'll say 6 over 4 volt thing, and then we have a capacitor here, and we're just looking for the resistor here. But remember, to DC, this is a open source. Yeah, it's an open source to DC. So that essentially means that that we're looking for the voltage difference across here, but there's no current, right? So the voltage difference is just 0. So VO prime is equal to 0 volts. Okay, any questions? I'm happy to answer. Okay, sounds like we're good. Next source is this.
Go.
Yeah?
Yeah, I gotta go.
Okay, sounds good.
Yeah.
Nice to see you, Ronak. I'll talk to you again soon, probably. Good luck with your lab. Hope everything goes well.
Yeah, thank you.
No problem.
Also, by the way, for PCS, how do you study theory? Because I think that's what I'm struggling.
Honestly, I'm just trying to get all the homeworks done, and I'm just reading Jasper's notes, and I'm trying to type my own notes, and that's kind of how I do it. I don't really, I don't really have a good way of doing it. I'm not doing that good in physics, so yeah. Sadly, that's the best answer I can give you.
It's okay. All right. Thank you.
No problem. Have a good night.
You too. Bye.
See ya. Okay, so then here, we're looking for this voltage across here, right? This is a 1 farad, so I think, well, I gotta switch it to phasor domain, right? So this is 6 over pi to an angle 0 degrees. Well, whatever, I'm not gonna rewrite everything. And this is 1 over j omega c. So j pi over 2 times 1, right? Which is negative 2 over pi j. Yeah?
I have a quick question. Why'd you write VO prime is equal to 0 volts?
Well, what's the voltage across this resistor if that's an open circuit here?
6 over 4, no?
If this was a closed circuit, it'd be 6 over 4. But it's an open circuit, right?
Oh, okay.
That makes sense?
Okay, yeah, that makes sense.
Okay. So then I'm looking for this voltage difference, whatever, it's, I'll just do nodal, I guess. I don't know. There must be an easier way of doing this. No, I can just do voltage division, can't I? So this is a what ohm resistor? It's a 1 ohm resistor. So it's just going to be VO double prime, that's VO double prime, is equal to 6 over pi to an angle 0 times 1 over 1 minus 2 over pi j. So you do the voltage of the thing that you are looking for the voltage over, sorry, the resistance of the thing that you're looking for the voltage over the sum of the two resistances, if I remember correctly. So VO is equal to, let's take a look. So I'm just looking at the solution. So we got it right for that part. Why did they write it like that? What? Oh. No. Does that make sense? If an angle negative 90. I'm just confused about one thing here. What did they do? Let me look at the next page of the solution. I think it's actually okay. Oh. What? That's so weird. What? I don't understand what they did. For AC, this is what they have. This is the entirety of the sine and cosine part. I'm about to show you. I mean, we can do it our way and see if we get an answer, but very little writing. That and that. And that's the final answer. That's right there, that's the final answer. So some reason they're multiplying two things together here. Some reason they have a 6 over pi minus 6 over pi j. I don't even know where that's coming from. I think that's, is that the source is equal to that? No. There you go, 6 over pi. Yeah?
I think I know what they're saying. So, you know how it says 6 pi angle 0 plus 6 pi angle negative 90?
Uh-huh.
Yeah, so the 0 one, that is for, I believe that's probably for the cos one, and then the negative 91 is
I
for the sine.
see. I see. That makes
They're
sense.
doing the entire, like both steps and both like processes in just one
Okay.
step.
So you don't have to do that, but they're doing a smart thing. They're saying that since these have the same frequencies, we can count them at the same time. We can do it at the exact same time. We can just put them in series with each other, right? We can just say this is the AC part. You know, it's convenient here because in other cases we're not that lucky, right? But here we are lucky. So here we're gonna have another 6 over pi sine pi over 2x term right there, and so that's in total this source right here. In total, this source right here is 6 over pi to an angle 0 plus 6 over pi to an angle negative 90, because the sine term up there, right? That's the equivalent of the source here. And so that's going to be, well, 6 over pi to an angle, what is it? 6 over pi to an angle. Oh, they just didn't do it like that. Never mind. Sorry. Yeah. 6 over pi to an angle 0, 6 over pi to an angle negative 90. Yeah. Oh, that makes sense. So they just said this is 6 over pi. Well, it's not 6 over pi anything. It's 6 over pi minus 6 over pi j hat. Because that's just 6 over pi, and that's minus 6 over pi j hat. So now to figure out VO, all we have to do is we just have to multiply 6 over pi minus 6 over pi j hat times that impedance. Well, the voltage, still doing voltage division. And, whatever, this turns out to be, by whatever's, I mean all the rest of the stuff, 2.224 minus 0.494 j hat. And since the DC component was 0, VO double prime is equal to VO. So essentially what we did is we broke VO up into VO prime and VO double prime, no triple prime, right? And so that is that, and this is 0 for the DC component, right? And so that's equal to VO. Okay, there we go. That makes sense to me. But any questions? Okay, sounds good. Let's try a practice from the textbook then. Let's see if that's any better. I gotta find fundamentals, electric circuits, and
By the way, what was the answer for that? 2 point.
there.
Okay.
Good. Okay, so let's give this a try. 17. Where is it? There we go. 17.18. Let me do this again. Okay, 17.18 problems. There we go. Okay. So, so right away to symmetric considerations. Determine the fundamental frequency and specify the type of symmetry present in the following functions. Okay. So the fundamental frequency is just 2 pi over the period, which is 2 pi over 2. So pi. And so pi is the fundamental frequency. And specify the type of symmetry. So it has um, uh, no sim. Oh, odd symmetry. It's an odd function. Yeah. I guess I'll check my answers. If I'm just talking through this, I may as well check the answers while we're going. 17.8. Okay. There we go. 17.18. They do not have answers for. So no luck. But well, then that means I guess I should check Slater. Just want to make sure that we're getting it right. 17 problems. 18.
By the way, Bala said that like in these types of questions, let's say like your graph is like not like centered around the x-axis, then like if it's like above the x-axis, maybe like 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 the middle region,
Mm-hmm.
where like you see like the origin, right?
Like
Yeah,
this
like
one?
this. So if you have something like this, you have to like get rid of the DC part. So you like by that I mean like you have to move the graph down to like you have to move it so that like the middle part of that graph reaches the x-axis, and then that way you can like confirm if it's odd symmetry or even
Oh, I
symmetry.
see. Interesting. Yeah. So you don't take into account the DC component there. Otherwise, it is. Yeah, I guess that makes sense. Yeah, it's just like
Mhm.
an a term at the start. That makes sense. So this one, I would say. So the period is one, two. Oh, for this one, okay. The period is 3. What did they ask us at this one here? I'm just gonna scroll up here. Find the fundamental frequency omega 0. So that's 2 pi over t. Here they're not doing 2 pi over t. Here they're doing 1 over t. 1 over the period for some reason. In the solution is later. They're just doing 1 over the period, which is weird. I don't know what's up with that, but all right. But it is symmetrical about the y-axis, so it's even. This one is also symmetrical about the y-axis, so it's even. The period is, well, it's going to be, the period is 4, right? So there we go. That's everything. Okay, and that's all. So that was all
Would it
right.
not be two?
It'd be 4 because to repeat like from peak to peak it's 4.
Mhm.
But if you were doing the Fourier series, you'd say from -2 to 2.
um okay, but like since this is like even symmetry, right? So wouldn't that mean that you're like pretty much like to making like a mirror image from 0 to 2 on to like 2 and 4, 2 to 4?
It's not exactly a mirror image, right? Because look at it. It's from 0 to 2. You have like you're starting up, going down. From 2 to 4, it's not exactly that. It's going up, same shape, but going up.
Okay.
If it was like 2, if the period was 2, it would look like this.
Oh, it would be like compressed or something.
Well, I think it would look like this. It would go. We do it in blue. It would look like this, and then like this again.
Oh, I see.
Do you see what I mean? That would be
Yeah.
what it would be if the period was 2. Right? But that's not what we have. So, okay. Anyways, that's fine for that one. Then, where is it? There it is. So, 36. Is this circuit applications? Yeah, good. 36. Find I naught where V of t is shown in this figure. Well, do they want the exact current? That's everything? Yeah. I guess they want the exact current. They don't want just to approximate with a certain number of terms, I guess. That's fine. Okay, so... Oh, I need the circuit too, of course. What are we talking about? That's the circuit? Yeah. Okay. Okay, so... just this... Okay. So we want to find I naught, where v of s is shown, or vs is shown. So first of all, I need to figure out the Fourier series of this. So I would say, well, it's going to have to be like let me just see. Periodic reflection. So the period is 1. Okay, so t equals 1, obviously. And so I can do the Fourier series from -1 to 1. Let me remember how to do this exactly, because it's like one of those extension things. Cosine series p equals L over 2. Yeah, I think that's fine. P equals 0 to L. Fourier series. Just trying to see if this is going to make sense what I'm about to do. Okay. So if I do the Fourier series... Okay, I'm going to look at Slater. I'm going to see how Slater did it. And I don't want to start talking random math stuff and it not be right. Let's see how Slater did it, and then we can work from there. So, okay, so they turn it into... Okay, so over one period of t, we can say that Vs is equal to so just this line segment right there would be 10 minus 10t, right? So it starts at 10 and it has a slope of -10 going down. In one step it goes down by 10, right? But t goes between 0 and 1. And then we want to take the Fourier series of this and extend it periodically. But a Fourier series automatically extends it periodically, right? So I think we can do, let me just see this for a second here. We can do 0 to period. So 1 over 1 is 1, so 10. Okay, so they do radiant frequency omega. Fourier series at amplitude phase. Oh, I see. Okay. So from here, we can uh, start doing the Fourier series. They do the cosine series of it, right? Which just means that they do the 1 over p, 1 over the period, da 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 da. Yeah, this is what they write. A0 equals 1 over t integral 0 to t of f of x, or whatever, vs of t dt. Specifically, of course, they mean, vs of t dt. Why is it equal to that? So them doing this tells us, I'm trying to just compare it to like the math formulas, right? Why do we get this?
I'm pretty sure Andy like gave those formulas to us.
Did he? Yeah.
Yeah, in the lecture, like this is the only formula that he used, and I think Bala is also using these formulas. So for like a of zero, it's just gonna be one over t integral of from zero to t, and then ds t dt, and then for an it would just be two over t, and then integral 0 to t, and then vs t cos whatever dt.
It would be 2 over t for an.
Yeah, for an, yeah.
Uh,
And like based on like whether
oh, I see. Yeah. Yeah. Sorry.
so I was
Yeah.
saying like based on whether you have like an odd or even function, you can just like make an a, and if it's odd symmetry, then you can make an equal to zero. If it's even symmetry, bn equals zero.
So we're essentially doing the we're essentially doing a
How?
cosine series here. That's what we're essentially doing. Like out of the, you can do. What'd you say?
No, no, like why? Wait, what do you mean cosine? Aren't we
Because
for
the
a zero? Aren't you just doing vt?
yeah. Well, a0 is just vt, and then remember in Fourier series, there's like the regular Fourier series, and then if the function is even or odd,
Oh yeah,
you're
yeah,
doing
yeah,
a
I
Fourier
understand.
cosine or sine series.
But in this case, Bala, I even asked him in like one of his lectures. You know how like when it's an odd symmetry, you also disregard the a zero, because
Yeah,
like in math we learned that a zero and a n are completely like zero. But he said that like in this case, we only change the a n or b n whether it's based on whether it's like odd or even.
yeah, because
You
sometimes
don't.
there's some sort of DC component, I guess. Yeah,
Yeah, they're like there's always supposed to be a DC.
I see. Okay, this actually does make sense because of how everything works out. Because the I was just confused. There should be a 2 here, but in math, f of t, the Fourier series is a naught over 2 plus the whole sum. But in ELE we never do the over 2, right? So it's just a naught, which is the DC component. And so that's because we've essentially divided it by 2 here, because really this is supposed to be a 2 over t. If like we're exactly following the math, it's supposed to be a 2 over t, but it's just a 1 over t because we can divide it by whatever. We divided it by 2 to get that. That's what was confusing me, but that's fine as long as we copy the formula. It's all good. So then here, yeah, that makes sense. So we're saying it's even by doing this. We're saying it's an even thing like this. That doesn't really make sense because an even function wouldn't the even
Oh
function
no,
look like
but
that?
no, no, no. Like what? Like the reason that we use those equations, like we use all three. Like it doesn't matter if it's even or odd. Like
Oh, okay.
you're supposed to use a zero, a n, and b n, but like this function, it seems to be an odd function, right? Because if you like get rid of the AC component, or sorry, DC component, if you move the like function down, then
Mhm.
on like the y-axis, on the other side of the y-axis, it's going to be an odd function, right? Because like take a point between 0 and 1, like just pick a point,
Yeah, you can
and
go
like
back
try
one
to see
period.
like where that point lies on the left.
Yeah. Yeah, that makes sense. Okay, so it's odd.
Yeah, so a n would be 0 in this case, then you would just find a0 and bn. But if it's not odd, if it's neither odd nor even, then I'm pretty sure you're just supposed to use all three of them and find all three of them.
So either way, this is what we do, I guess, for the next one here. This is the
Yeah,
next thing. What over
just for
period?
a n, you just put a 2 over t, and bn you just put over, yeah, same thing, but just with the sign. But like all three of them, unlike in math, I know like we only learned like two, like we know that whether if it's like odd or even, you just use one or two of them. But in this one, you just gotta like you use all three.
So then why do we have the bounds like this? Why are the bounds 0 to t? I don't understand. Because I guess I'm like maybe I should just look at a different set of formulas for ELE stuff because obviously it's the same Fourier series, so it should be the same. But
I'm
there's
assuming like it's between 0 and t, because like that's your one, like you're considering that as one period, but then you're trying to divide it by t to find like the mean or average value where the DC component lies.
yeah, okay, I guess so. That makes sense. So 1 over 1 integral 0 to 1 of vs of t dt. So that's equal to 5. So there we go. So then we didn't even have like I just did it visually there. And then calculate an. So an is 2 over t integral 0 to t of vs cosine n omega 0 t. Oh, sorry, I'm reading out the Slater thing. Why n omega 0? What? That's n. Oh yeah, n times the fundamental frequency. Yeah, but I'd rather just do it as n pi over n pi over. Oh yeah, no, I can't do that though.
Isn't it 2 pi in this case? Because our period is 1, so 2 pi
Yeah,
over, yeah.
so it'd be 2 pi n here.
Yeah.
Hmm, interesting.
Also, like you can continue with this like process, but like an would be 0 in this case. Just like you can like just do the process anyways, like to like confirm. But an would be 0 in this case because the function in the graph is odd.
The function of the graph is it's odd, so you
Yeah.
get that.
But like just continue this process so
Okay, yeah.
like we can like better understand, I guess.
Yeah. So that's 2 integral 0 to 1 of, well, so I'll say 21 minus t because just factoring out a t there. Cosine 2 pi and t. Okay, then I got a whole thing to integrate here. Yeah. We can look at this later solution. So there's not really a point of me rewriting everything if I'm just really looking at this later solution. So they calculate an. Really, the hard part is just setting up the equation here, which it just doesn't make sense to me. Like comparing it to math, like I don't know what exactly we're doing here, but yeah, I'll figure it out. So 2 over t 0 to t vs and omega t, you get 0 there. For bn, it's the same thing, so it's going to be 2 over t 0 to t, and that's that. And then now that they found an, they found a0, an, and bn. Then you can figure out into equation 1.17.3 or 17.3. No, that's just the Fourier series. Whatever. There's nothing else to think about there. Yeah, that's fine. And then omega n is equal to 2n pi. Yeah, that makes sense. And then they transform the circuit into time domain to the frequency transforming the time domain components of the circuit to frequency domain. Sorry, yeah, they could transform it there. So it's n omega 0 c and n omega c. So that's fine that they just do that there. Find the response of the DC and AC components. So they do just some sort of current division. Or let's look at the circuit again. Where's the circuit? So if you know this, you're looking for the current. Well, the current is just going to be, I is going to be V over R, right? So this voltage, the DC one, over R, the combined resistance, which is nothing crazy. So V over the combined resistance. And then I0. Oh, you just want to set n equal to 0 to find the DC component. That makes sense. So you get 0. And then they do the whole process like fully in AC. But I think we're ever going to be expected to do this in this course. To fully do it in terms of n is what I mean. Right? I don't think we're expected to do that. Andy said.
Yeah, sorry for interrupting.
No, I was gonna say it's just that Andy said he did one example fully with n's, and he said I think he's pretty sure he said fully. He confirmed you're not expected to do this on the test.
Wait, really?
You just do it. You just do it in terms of like they'll just tell you how many terms to use. You're never gonna do it with n. You're gonna do it. They'll tell you like use the first 3 terms or something like that.
No, because like there like most of the questions in the textbook they're mainly like in terms of n. That's why.
Yeah, really.
I think he did say that like there might be there might be a question where like the question itself might ask you to just like analyze like the first 3 like values from like right from the beginning.
Yeah.
So like you might not have to like even like do the like derivation or something like that. I don't know.
Yeah, I agree. Yeah, I think you won't have to. It's just yeah, I think it's pretty much just that. So that they do it here, but then obviously that's more complicated. Okay, let me see. I think I have to do a little bit more reading of the textbook because there's something that's not sitting right with me about how we're doing the Fourier series. It seems sort of random. Like I don't even know what rules we're following here. So I got to read the textbook a little more. I wanted to only go for about an hour today anyways, and then we try things. So it's good that we did the practice test one. I think that made a lot of sense. And it's good that makes a lot of sense, the one that's on the practice test. Because that's probably similar to what we're going to have. And then from there, I gotta read the textbook a little bit more. Maybe I'll look at some of his notes. Figure that out.
Also, can you send the Quizlet solution for the like